Hi, Science 10. So what I want to do today is go over the answers to the first three pages. We already essentially did the entire first page, so just the second and third page, and then I would like you to finish off the remaining three pages. Okay. So we did a couple of these, the first one, the last one. So let's look at the second and third. So there's your change in t, which is a change in time, 2.8 seconds. If your final is 8.5, then your initial has to be 5.7. So how did I get that? You go 8.5 minus 2.8. So what you're saying is 8.5 minus 5.7 equals 2.8. And remember, your time always has to be positive. You're given the change in position displacement, 5.8, positive. Okay, so that tells you if it's positive, you're going up. Okay, you're going in the positive direction. And then your initial is 24.3, so your final has to be 30.1. Okay, yeah, that's 30, not 36. Okay. This one here, north, south. So remember, north is positive, south is negative. So this one you're going south. Okay, and then this one is your change in time is 18.2, so your final is 38.4, initial 20.2, and then your final is 24.8. So your initial has to be bigger in order for you to get a negative, right? And so that's the value there. Okay, let's look at number two. Some of you were confused by this one. This is a good question because it basically distinguishes distance versus displacement. Okay, so in brackets, north, east, south, and west. Okay, so we're going 2 meters north. So this is your, because they mentioned that the 2 meters north, this is your starting area right here. Okay, you're going 2 meters north, 4 meters east, 2 meters south, and then 4 meters west. Okay, so what is the total distance? So the total distance traveled, okay, is the sum of all these numbers. So that's going to be 12 meters. Okay, and what's the displacement? Well, your distance traveled is, remember, this is what we call a scalar, which means that it doesn't factor in direction. So it's just the magnitude only. So this is the distance we traveled. Displacement is vector, which means that it takes into account the direction you're going. Okay, so it's magnitude and direction. So if you started here and then you went all the way around and you returned here, then your final position is equal to your initial position. So your displacement here is 0 meters. Okay, so it's as if you never even went anywhere. Okay, so displacement simply looks at relative to where you started out, where did you end up? Okay, so if you end up back at the same spot, regardless of what you do in the middle, your displacement is going to be 0. Now, a question kind of like that was on the next page. This one you might have been a little bit confused by. So you've got A, B, C, and D. So these are different periods of time. So beginning with A, so that's a time 0 minutes. So basically at the initial. So that's your initial position. And then here's 1 minute later, and then 2 minutes, and then 3 minutes. Okay, so it says it's saying for each of these times, it wants you to give the position. Okay, so position is also a vector, right? So it has to do with where you are. So 0 minutes, we're at a 0 position. At 1 minute, we're all the way over here. So relative to your at time 0, there's 40, 100, and another 40. So that's 180 meters. Okay. Now, you always, when you're looking at a vector, you want to give all the information that you're aware of. So we know which direction we're going here. We're going to the right, which is east. Okay, so that's 180 meters east. Okay, at 2 meters, at 2 minutes, we're over here, and that, now you might be saying, well, how's how is this one 40 meters east when this one is 180 meters east? So again, we're not looking at what you're doing in between. We're simply asking at this time, what is your position? Okay, and so here's your 0 spot. So relative to the 0 spot, we're 40 meters east. At time 3 minutes, we're at 40 plus 100, so we're 140 meters east. Okay, so again, position simply looks at that specific time frame, where are you? Okay, it doesn't, again, we don't care about what you're doing in between. We just care about what is your position at that time. Okay, now this next table here, it kind of factors in what's going on in terms of looking at things in terms of distance and in terms of displacement. So from 0 to 1 minute, you traveled 180 meters. Okay, so again, that's not, that distance is scalar. Okay, so this is scalar, and this is vector. Okay, so you should be familiar with the differences between these terms. So again, these are terms you assign variables. A scalar variable is magnitude only. A vector variable is magnitude plus direction. Okay, so from 0 to 1 minutes, we traveled 180 meters. Your displacement from 0 to 1 minutes is 180 meters east. Okay, 1 to 2 minutes. Okay, so 1 to 2 minute is looking at beginning over here. Okay, so beginning over here. This is 1 minute, and ending off over here. Okay, so what's the distance you're traveling from 1 to 2 minutes? So we're going this way, and so it's 40 plus 100, so it's going to be 140 meters. Okay, and what's your displacement? Your displacement is going to be 140 meters. Now we're going left, which means we're going west. Okay, so it's 140 meters west. Okay. And remember, 180 meters east, that would be, another way to represent that would be 180 meters positive, and this, another way to represent this would be 140 meters negative. Okay, so negative and west in this case would be the same thing. So you just need to do one or the other. Okay, 2 to 3 minutes. So now we're starting over here, and then we're going all the way to over here, right? And so here you're traveling 100 meters as far as your distance is concerned, and your displacement is going to be 100 meters east. Okay, so what's the total distance traveled after 3 minutes? So the total distance, so taking into account all that's going on here, it's going to be 180 plus 140 plus 100, right? So that's going to be 320 meters. Okay, what's your displacement? Okay, so your displacement, again, is looking at it from the perspective. Here's where we started, right? So that's where we started, and don't care about B, don't care about C, I just care about the final position D. Okay, so you're just looking at these two. Okay, so you started over here initially, and your final position was over here. Okay, so who cares what happened here and here, right? So that's what displacement's looking at, your final position relative to your initial position. So that's going to be 140 meters, and that's going to be east. Okay, so on a quiz or a test, if you don't put if you don't specify the direction for C, it wouldn't be completely correct. Okay, so you want to make sure if you're solving for a vector, and this is true if those of you end up taking physics 11, if you're solving for a vector, you have to indicate the direction. Okay, distance, direction's irrelevant. Okay, so you don't put it in, but we do for displacement. Okay, so hopefully that makes a little bit more sense of what you're doing with this sheet. So what I'd like to do now is just finish the other three worksheets that were attached with this post. Monday is Victoria Day, so we won't have a class on Monday. So the next class we'll have is on Thursday. Okay, so you have a week to finish those 3 remaining sheets. Okay, so it should be plenty of time for you to be able to get that done. Okay, so I'll stop. I'll stop there. And some of you were sending questions on how to do this, so that's great. So with the next 3 worksheets, those of you having difficulty, make sure you send me a message, and I'll help you out with that. Okay. So again, stay safe, and I'll talk to you again on Thursday. Okay. Bye now.